Alright, well today I'm going to be experimenting with these two batteries. Both of these are made by E-Flight. I'm guessing they're about 5 years old. They came with one of my RC airplanes. As we can see, it's a 3-cell, 11.1 volts, and then it's 1,300 milliamps, and this one's same specs but 2,200 milliamps. Another thing that we can note is they're incredibly puffed. The cameras are slimming it down. But these have an incredible amount of puff. I showed these to guys at the local hobby shop, and they're just impressed that they haven't blown up yet. Well, I figured, well, actually, why don't we see if we can blow those up? So what we're about to do is go outside, and then we're just going to charge these things until ultimately, hopefully, the batteries fail. Let's give it a shot. All right, well, here's the setup I'll be utilizing. We're going to work with this battery first. So for this, we're not going to do LiPo mode. We are first going to, actually here, let's plug this in to the 3-cell slot. So these haven't been charged in 3 or 4 years. Let's go to battery meter. Simply look at them. No way, seriously? Okay, well, according to this, my battery is completely dead. 1, 2, 3, 4, 5, and 6. Oh, this only has 3 though. Are all completely dead, reading 0, which is incredible. I've never had a battery that low. So I'm going to go to digital power, select. We're going to adjust this. We want it to be at the rated voltage, maybe just a little over, but because of some electric stuff, it'll automatically bring it down, and then we'll charge at up to 1 amp. Generally, that's a bad configuration. You'd want to start really low, amperage-wise, if your battery was as dead as this thing is. But since I'm okay with it blowing up, we're just going to see what that does. So here we push and hold. Here it goes. Voltage, as you can see, this goes all the way up to the 1 amp, and then the voltage can't get any higher, again, because of resistance, electrical, Ohm's law stuff. Okay. So now we're just going to let this sit, and hopefully something interesting happens. We're up to 9 volts, which is pretty high. Yeah, see what happens. Your total voltage swing should be those 1, 1, 1. So obviously your full charge should be about 12.6, and your all the way drain is going to be about 9.6. So we're up to 10.2. So let's actually go ahead and inspect what each cell is doing. Our cells, so cell 1, you can tell, is basically dead. It's probably the one that's the most puffed up. It's 2.1, up to 2.1. They're all draining, as you can see. 3.2, like I said, that is completely drained. So that's the lowest you ever want to see your cell, and then that's just a little above. So I'm going to go ahead and unplug it from here to the charger. You can't tell that, again, we're doing something we're not supposed to be doing. Obviously, the internal resistance is not great. As you saw, the values were plummeting there. I'm going to go back to digital power and resume. Yep, we're back up to that 1 amp, plus or minus a little bit. Hopefully cell 1 will take a little bit more charge here, because it's smart enough to know that even if one cell isn't working, it won't let it charge. So what we'll do is, if we can get that one cell to the minimum voltage without achieving, to that voltage without overcharging any of the other cells, that would be great, because then I can plug it in, I can charge it normal, and it can individually balance through those 3 leads which cells get the power, and it can charge them all individually up to full. That way one's not low, and then the others are overcharged to make up for that. Alright, next we're going to go ahead and just inspect. So as you can see, our amperage is dropping because we hit our 1.1. There we go. See how this one was forcibly brought up? And these are still not yet charged. All right, perfect. Before everything drops below what it needs, I'm going to go to LiPo. It's lithium polymer. 3-cell there. That's a really high charging rate. So we're going to go ahead and lower that a little bit. We'll go with like 1.5. Well, I'm going to go ahead and let it charge like this for a little bit. So what that means is that the cells got up to an appropriate voltage, and it now treats it like a healthy battery. And we'll see what happens. This right here is the amount of energy total that goes into it. This will be the amount of time. That's the amount of amps. That's the amount of volts. All right, well, we're switching to the bigger one. My final numbers there are 9 amps at 12.6. Oh, that did so not disappoint. Oh, that is so cool. That is a fireball. See the lithium? It burns blue. All right, there's my contacts. Those are safe. Oh, wow. All right, well, all the experimentation is done, and these are my results. First of all, this one, which I charged at a responsible rate and then stopped overcharging it just for because I was curious if I could actually use it, and I actually thought it would be used for a battery this size. And it was fairly successful. Obviously, this isn't going to have amazing capabilities. Something that I noticed is it's less puffy. Like, it's obviously been stretched out. You can see, and maybe you can't see how wrinkled that is because that was tight, but now it's slacked out. Charging it again seemed to like shrink whatever cells a little bit. I'm surprised by that. I would not recommend again doing this. It's going to be a terrible battery performance wise, but it's better nonetheless. Here is a good battery of that. This, nice and hard. This, you can hear that it's poofy. It's buffering my hit. And then this one, this is all that's left of that other one. It just covered mine black. I could bring the actual carcass of the battery, but since there's lithium in it, I didn't want to touch it. I'm going to dispose of that responsibly because, yeah, lithium's no joke. I have a little bit of a sore throat after that, even with a whole bunch of positive ventilation in the area. All right. So, yep, I hope this guy was at least informational, so you guys didn't have to blow up some of your own batteries to see what would happen. Kind of an example of exactly what not to do. Thank you.